Can you hear me, please?
Yes, sir.
Yes, sir.
Okay, that's
Yes,
very
sir.
good. Okay, so let's finish it up strong. Okay, my lights are out, so I don't know how long I can sustain the class. So let's let's finish it in due time. Okay, so welcome. Today we are going to continue with our lecture. Last week we were looking at arrays, and we saw excitingly how to deal with single-dimensional arrays and two-dimensional arrays, how to print elements from an array, how to post the elements, how to get things into an array, and all sorts of business that has to do with arrays. Now, today we are going to look at how to deal with functions. Okay, functions are an important part of modular or object-oriented programming, and in fact, for structured programming, it is very, very, very important. It's at the core principle of program design in structured programming. Okay, so we are going to, once you learn about functions here, you can apply that knowledge everywhere that we need to write computer programs. Okay, so we're going to talk about functions, what they are, how a function looks like, types of functions that there are in most programming languages. Okay, then we'll go ahead and look at how we as users can write our own functions. How do we go about writing our own functions, as user-defined functions? And when we write functions, we have mainly two types of functions, okay? Functions that return a value and functions that do not return a value. So how do we return a value? And then we'll talk about the details or with regards to the details with regards to parameters. Okay, how do we deal with parameters? Pass by value and pass by reference. And then we'll to look at how or the scope of identifiers or the scope of data that we pass to functions. So let's jump right in. Now, basically, when we say a function, we are talking about just a collection of statements which do something specific. Okay? So a function is nothing more than a collection of statements which do something specific. Right? Now, for example, if I have a very big program and the program does so many things, okay, the program, maybe the program prints some output, the program generates some input, the program, how do you call it? The program returns some value, the program does so many parts of the program doing so many things, but basically the structure of the program is such that there is input, there's processing, there's output, and it's doing different things at a time. Then what you can do is that you can group the parts of the program which are doing something specific into one function. Okay, so it is important to note that the parts of the program which do something specific and do not affect all the other parts or the other parts of the program are what we can regard as functions. Are we okay? Okay, so functions break the program down. Okay, we have a very long program or very big program, and if, for example, we have an error, how do we locate or correct the error? Okay, it will be virtually impossible to locate errors in very big programs or correct those errors in very big programs. But if we use functions, then what it means is that, or if the program is grouped into functions, then what it means is that when the user or when the program is running and there's an error, we can know the specific parts of the program where there is the error. So functions act as a miniature version of the program. Let me use this to depict. So for example, we have a very long program, okay, maybe about 100 lines of program. And then we run in them and then we get an error, okay? We result in an error. Now, if we have 100 lines of code, we have to read through and identify where the error is, make the correction, and then rerun the program. It will be very hard to do that if we have a lot of lines of program. But if we have another version of the program written as functions where each part of the program is doing something very specific, Then when we have an error, we could only go to the part of the program doing that specific thing, correct the code, and then the program will run again smoothly. It will even be easier for us to identify where the problem is within that program so that we can make the necessary corrections. Okay, so functions allow us to do that kind of thing. And most importantly, if there's also a specific part of the program which is doing something specific, it means the next time you have another program to run, which will also do something specific.
Hello.
Hey, so you like to know Dumana? ECG
Yeah,
has done it.
yeah, Akim, they ask funny questions. So, I'm sure his microphone went off.
Okay, can you hear me now? Hello?
Yes,
Yes,
please.
sir. Yes, sir.
Yes, sir.
Okay.
Welcome back.
Yeah, I don't know how I got off. Please, let me be hearing you so that I know when I go off. Okay.
All right.
I didn't know when everything went off.
Yeah, yes, yeah.
Okay. Okay. So did you understand the explanation, or that part also went off?
So you were saying that when you have a function and you are writing another program, then you went off.
Okay. Let me explain. So basically, like I said, like I was saying earlier, a function is groups specific parts of the computer program together. So, for example, usually when we write programs, because of the way the idea,
Hello, what's up? Hello.
hello, the
Yeah.
gentleman who's talking, hello, hello, mute yourself.
Yeah.
Hello, mute yourself. Okay. So back to what I was explaining. So because of the way the idea is structured, you may have to write several lines of program. Okay. Now, if all of these several lines of program are written as one long program, it is difficult to identify where or when there is an error. Okay. It is also difficult to identify where there is where there is maybe any part of the program doing something misbehaving or doing something malicious. Okay. Now, if there's an error maybe on this line, you have to read all of this all the way here before you can find the error and correct the error. Okay. And then rerun the program. But if you break the program down into its constituent parts, okay, Now, when there is an error, you know exactly which part of the program has the error, and you can go there and do the correction on that part only. In fact, you can replace all of that part with another equally running or good part of the program. Okay, so that's what the power of functions is. Functions give you the power to write programs which are reusable. Okay, reusable. Okay, and then they are also what we call modular. Okay, modular means that we break the program down into modules, into small chunks. It is better to work with small parts or pieces of the program than to work with the entire program as one long list or line of code. Am I still on?
Yes, please.
Yes, yes.
Is it understood now?
Well understood, sir.
Okay, that's good. Okay. Now, what is the importance? So, like I was saying earlier, one main importance or key importance of functions is that it allows you to break the program down into modules. So we say modularity, meaning that when you divide the programs into small specific parts, you can better manage the program. When you know that, oh, I'm only writing this part of the program for this function for printing the values, or this function for doing area, or this function for doing radius, for doing circumference, or this function for doing volume. You know that you are focusing on something specific. You can manage only that thing. Once you are done with that thing, you put it aside and you pick the next thing. But if you are writing everything together, it is not manageable. Okay, it's sometimes the reading it alone is a headache because the program is so long and so hard to read together. Okay, then it makes it also easier to maintain the program. Okay, programs which are broken down into functions are easily maintainable. Okay, you can maintain it, you can debug it. Debugging is just removing the bug. Okay, so or removing the error. You can modify that program very easily. You can test or isolate only the things you need to test. Okay, functions also help to keep variables local. What it means is that memory can easily manage the program. Okay, but if the variable is global, then you need a lot of memory to run the particular program. And then functions also do something we call encapsulation. So encapsulation is the way we hide the information. We keep the information in capsules so that only specific parts of the program see specific things. Okay, it's just like how we do privileges when we have applications, okay, so that only admin can do everything, users cannot do everything, and that kind of thing. Okay, we have encapsulation in programming where if we make something visible to everybody, we call it public. If we make something visible to only specific classes, we call it private. And then we can also be selective about the visibility. Okay, so this is also one of the key things. Now, there are two main kinds of functions. We have what we call built-in functions, and then we have what we call user-defined functions. Now, somebody will ask, okay, so what is a built-in function? So a built-in function can also be called a pre-defined function, meaning that it is already written for you. Okay, when you download C++ or you go and download Java or you go and download Python, there are some functions which are already there in the programming language. They have been written by the developers of the programming language so that you can easily do certain things you want to do. For example, if you go and download C++, there's a nice function called cout. This one allows you to print things. Okay, you don't have to write from the scratch all of the code which will allow you to print. No, that code has already been written for you, and all you need to do is to call it. There's also a function, for example, called getLine. Okay. GetLine is the function which allows you to get something or get a string from the keyboard. Okay, so all of these are stored in something called the standard library. Okay, the standard library is where all of these built-in functions are kept in the various programming languages. Okay, so we have some examples to show you over here, and I added more examples for you. Okay, now the second group or the second category are called user-defined functions. They are called user-defined functions because you, the user or the programmer, you are the one who writes them. And the difference is that the one that is written for you, everybody who downloads C++ can see them and use them. But the one that you, the programmer, write yourself inside or on your computer is only available on your computer and not on anyone else's computer. Okay, so some programming languages, there are ways you can create functions. Okay, in C++, for instance, if you want to create a function, you first write maybe the data type of the function. Then you write maybe the name of the function. Okay, so usually function names start with lowercase. Okay, then you write a parameter list. Then you write what the body or the code should do. And then once you are done, you write the return type of the function. And then you end it off. So basically, there's a way to do it in every programming language. Okay, there's a way to do it in every programming language. So what we are going to do here is just generic. Try to see how functions, what they look like and how they understand and how to look at your code and break your code down into functions. Is it understood, please?
Yes, sir.
Yes, sir.
Okay, so we are just going to look at user-defined functions since we are not doing any specific programming language. Okay, so when we create a function, just like how we talked about with regards to variables, in programming, you cannot use anything without creating it first. And in programming, when you are creating something, we call it declaration. Okay, so how do we declare a function? Okay, now functions have two important things you need to take note of. The declaration, the declaration, what is that? Okay, sorry, the declaration part, what is happening? The declaration part and then the definition part. Okay, now the declaration part of the function is the part of the function which contains the name of the function, something called the return type of the function, and the parameters of the function. Usually, we call this declaration part the header. Okay, the header is just a name we give to it. Okay, the header of the function or the function header. That's the head. The head contains the name, the return type, and the parameters, if there is any parameters to add. Okay, then the function definition is the declaration plus the body of the function. The body contains the code which you want to run. Okay, so please recall or please take note of these two important things. The declaration is the name, the type, and the parameters. And then when I say the definition, I mean the declaration and the body of the function. Okay? So let's look at an example. Oh, hello, the gentleman whose microphone is on and is talking. Hello. Your microphone is on and you are talking, please. Mute it down. Mute it, okay? Thank you very much. Okay, so let's look at an example. Let's look at a function declaration, and then we look at a function definition, and we see the key differences, okay? Now look at the two things. Remember, this one is in This one is written in pseudocode. Okay, so please recall that it's written in pseudocode. Okay, this is not in C++ or in Java or in any language. It's in pseudocode. So please take note of it. Okay, so in pseudocode, in order to differentiate a function from the rest of the program, I'll write the keyword function. Okay, so when you see function, notice that I'm writing this function. Okay, then, oh, sorry, let me go back. Okay, so this is the keyword, right? This is the keyword. Then this is what we call the return type. So what I was talking about, the return type. Okay. Then this is what we call the name of the function. So the function name. Then these three important things are what we call the parameters. Okay. So when you write this this function this way, we call this way of writing the function declaration. Here we have only the return type, the name, and the parameters. Sometimes we call it the function header. Sometimes we call it the function prototype. Okay, prototype. It's also another name we call it. Now, notice that there's no body or there's no code in this one. But when we have the header, okay, we have the function declaration, which contains the body. This part is called the body, okay? With the end of the function, we call all of this the function definition because it contains the code which makes the function work or run. Are you with me? Do you see the key differences? Hello, do we see the key difference between the function definition and the function declaration?
Yes, sir.
Okay, so the declaration is only the part of the function with the head, okay? The return type, the name, and the parameters. But the definition is everything that makes the function work. Okay, so that's the definition, everything that makes the function work. Okay, regularly, if you want to use it in a program, we'll have to do this. This is how we use a function in a program. I'll come and talk about it later. We call this one a function call. Okay, so it's very important. Without doing this, the function will not work. Okay, let's go to the next part. Okay, so now let's investigate further what we mean by function definition. So the definition, like I said, contains the statements or the body, the part of the function which is actually doing the work. Okay, and it has these following parts. It has something called the return type. The return type tells the computer or the program the kind of information you want from the function, the data type of the information you want from the function. So this return type can be an integer. Remember integer? This return type can be a float. This return type can be a character. This return type can be a Boolean. This return type can also be a double, okay, and so on and so forth. In addition, there's a special return type in computer programs we call void, okay? So this one only applies to functions. Void means that you are not returning any type, okay? So that's special when we are doing functions. You can't use it in variables, but you can use it in functions. Then the function name is the name of the function. Remember, the name must be a legal name. It must be a name you can use to name something in programming, okay? Then the formal parameter list refers to what? A list of the data we are giving to the function. So functions do specific things. So sometimes you want to give the function some information and let the function do something with that information and then return an answer to you. And that is what we call the parameter list. Then the body of the function is the code, the code that makes up the body, that is doing the actual work. Okay, so when you bring all of these four things together, these are the four things which form the function definition. Okay, let's look at them in much more carefully. So looking at them, you can see over here, have the anatomy of a function. When you dissect a function, you can see that I have the keyword. Then I have the return type. Like I said, this one can be int, can be double, can be float, can be void, can be any of those things. Then this one is the name of the function. Okay, so the name can be any word which is legal in programming. Okay, but you should not use the names of other functions. Okay, for example, if you have a function called print, then you create another function called print. The same name. No, you cannot do that in the same program. Okay, it's not possible to do that. Then we have formal parameter list, the data that you are collecting. For example, if I'm collecting radius, okay, radius I know can be a decimal, so I'll make it what? Float radius. Okay, and then I'll put that in a bracket. The parameters should always be in a bracket. They can be 0, 1, or more parameters. You separate, if there are more, you separate them with what? Commas, like you are seeing in the example I did earlier. Okay, then the code is what we refer to as the body of the function. Okay, now usually when the function return type is not void, you will normally have this line of code, which means that because it is not void, you are returning some value. Okay, when the return type is void, okay, you don't return anything. But when the return type is any of the other ones, like int, like float, like boolean, like string, character, like any of those other ones, you should have this return something over here. Okay, is it understood, please?
Please
Yes,
again.
sir.
Okay.
Hey.
Okay, so now let's look at some examples. Okay, so here I have examples. Let's pick them one by one. Let me label this example 1, example 2, example 3, example 4, so you guys can follow me. Okay, now let's go to example 1. So in example 1, look at the return type, then look at the name of the function. It is one word. Remember, in programming, when you are naming things, you only use one word. Even if there are two words, you have to join them into one word. And you cannot start the name of anything with a number. Okay, then inside the parentheses, you can see the parameter list, formal parameter list. Okay, so here there are how many parameters? There are 2 parameters. The actual parameters are what? A and B. Okay, A and B. But the int means that A is an integer and B is an integer. So what it means is that when you are creating your functions and you have parameters, you should make sure to tell the computer the type of information you are putting inside the parameters. It is very important. Okay, then the next thing is the body. Look at the body. So this is the only one line representing the body. Okay, so this body is just a return statement. Because it is double, we are also returning 2 integers. So you add 1, you add A to B, and then you give the value, you change the value into a decimal before sending it. Okay, so that's what example 1 is. Everybody understands example 1?
Yes, sir.
Okay, that's good. Then let's go to example 2. In example 2, the data type is what? Integer. The name is called what? Print hello. Look over here. So can you see that there's no parameters? So there are no parameters in example 2. So it's not by force to always write parameters. It's not by force. If your function does not require parameters, there is no need to have parameters. Okay? But
Yes, sir.
you should have body. Now notice that because it's integer, we are returning 0. Okay, even though we are just saying hello, but we are returning 0 as well. So you can see that over there. Let's go to example 3. Example 3 is where I use void. Void means you don't see any return. Notice that in the body, look at the body. There is no return. No return, okay? So look at the body, there's no return. So when you use void, you don't have to return anything. But when you use any of the other ones, you have to return something, okay? So please take note of the rules when you are programming. Okay, now let's go to example 4. Example 4, look at example 4. It's also void. The name of the function is called ans, okay? And the parameters are 2. What it means is that in your program, if you want to use this program, you have to call the name ans and then give it 2 numbers, maybe 3 and 5. Once you give it 2 numbers, it will send 3 to A and send 5 to B, and then use that to determine whether to print this or to print that. Okay, now notice that in the body there is no return because of void. Okay, are we okay, please?
Yes, sir.
Okay. Hey, no questions so far? Okay.
So we have questions.
You have questions? Okay. What's the
Yes,
question?
we have some questions.
What's the
Sir,
question?
why do we always return 0 and not any other number?
Oh, we don't always return 0. Do you see always return 0? Oh, why are you saying that? We don't always return 0, please. This is not 0, is it? Hello?
Yeah, hello, sir.
Do you see 0 here?
I mean, when you write the second one, you write return
And
0.
so it's only the
Otherwise-
second one you saw me do return 0, but you're saying you always return 0 of Ghanaians.
So the second one is just another example.
It's an example. So it's an example. I'm just returning 0. You're saying I'm always returning 0 for Ghanaians. My dear friend, I'm not always returning 0s, and it's not always we have to return 0. Okay, I'm only returning 0 in one example.
Mike, open 0, Dodo.
Okay, sir. So
One example.
Okay.
Oh, my you be
Okay,
brave,
sir.
but one pen I'm here. You know, we'll see. I'm always returning 0s.
Okay, sir. Example 2. Can you also return 1?
You can return 1. You can return anything.
Oh, okay.
Yes. Okay.
Hello,
Thank
sir.
God the light is back. Oh, you see. Okay. Yes.
Hello, sir.
Yes.
Please, good morning.
Any other question?
Yes, please.
Yes, I'm listening.
Sir, please, does it mean that I just want to make things clear? So
Yes.
if functions contain the data types, we return them, right? But
Yes,
if they
yes, yes, yes.
contain
That's
a
what I said.
function is a void. Oh, okay, okay. All right.
If it's a void,
Thank
you don't return anything. You can see it, the
All
void
right.
examples. You can see that the void examples, there's no return. Look at the void, no return.
Yes.
Okay, but the ones with
So only
the
data
double
types.
and int, yes, you see
Okay.
return. Okay.
All right.
Yes.
Oh, okay. Okay. Thank you.
Yeah. We are going to delve deeper into it, but I just wanted to make sure you understand that one as we start. Okay. Any other, or we push ahead?
So let's push ahead. My
Okay.
question has been answered.
Okay. So now, when you write a function, simply writing the function is not good enough. Okay? You can write the function, which is okay, but it's not good enough. If you want the function to work, you have to call the function. It's just like you having children, and you have kids, right? They can be there in the room. Maybe you need them to do something for you in the hall or maybe somewhere. If they are just there in the room and you don't call them, they are just there. Nothing will happen. Okay, you need to call them. So functions must be called to cause them to work. When you create a function and you want to use the function, you must call them. So the process of using the function is what we call function call. Okay, that's basically it. It's just a simple line of code which calls the function to come and do something that you want it to do. Are you with me?
Yes, sir.
Hello?
Yes.
Okay.
Yes, sir.
Okay. I just want to make sure I'm on the call. So function call executes the function. Okay. So how do we do this?
Hello, sir. Your line is breaking. It has started breaking.
Now look at this example I have. Okay, I have a function called print message. Okay, that's hello. Hello.
No, sir.
Yes,
Sir,
sir.
please. The line has been breaking.
But can you hear me now?
Yes, sir.
Yes, sir.
Okay. So
And sir,
let me try.
please, your screen is off. I don't know if it's only my side.
It's off.
Only from your side, please. Sir, please, we are having your screen on. We can see.
We can see
But,
your screen,
sir,
sir.
please, sir, please, your network is buffering.
My side is off. I don't know why.
Wow. Okay.
Only showing your name.
One moment. Okay.
Yes, sir.
Let me unshare and then reshare and see if it will work. Okay.
Right, sir.
But you can hear me.
Yes, they're hearing. I can hear you, but
Hello.
We can hear you loud and clear.
We can hear you, sir.
Can you
Can hear you
still
very
hear
well,
me?
sir. Yeah, sir, we can hear you very well.
Or is it still shaky?
No, it's
Not
fine.
sure.
We can hear you very well.
Okay. So I'm trying to share again. See. Okay. I'm trying to share again. Okay.
right, sir. Thank you.
The gentleman, can you see the screen? Can you all see the screen?
No,
Sir,
sir.
Yeah.
no, sir.
Taking it off.
What's saying,
No, please. No, please.
I mean the screen.
No, it's
No,
not coming,
please.
please.
We can't see
The
the
screen
screen,
is not
sir.
coming.
Hello. Can you see?
No, it's not visible
Yeah,
to.
not yet, sir.
We can see you now, boss.
Yes, sir. Please, the screen is back.
Oh, sir, it's visible now.
Vincent,
Vincent,
mute your
please.
side. Or is it that he's not closer to his phone?
Sir, your screen is back, but we can't hear. Your voice is not. We can't hear your voice, please.
We can't see your voice.
Okay. Hello.
Sir, you are
Yes, sir.
Okay.
Sir, you can see the screen now.
Okay.
We
Thank God. Okay, so let me continue. So, like I was saying earlier, function call is the process that you where you are calling the function to come and run. Okay, and notice that just like ordinary children, okay, when you have children, you can call them as many times as you want, and so when you create a function once, you can call it several times. Okay. So in the example, gentlemen, mute your microphones a bit, okay? Or keep quiet so we can hear. They can hear us over the voice, okay? Now, so in this example, we have a function called print me. It's a void function. All it does is to print. This is a function, okay? Then we have a program. This is a program down here, okay? If we want to run our function, we need to do what we call a function call, okay? So this line down here is what we call the function call, okay? And basically, the function call is just the name of the function with the parentheses. That's all, okay? If the function has parameters, you add the parameters. If not, then you just call the function with the parentheses, okay? And you can call a function as many times as you want. So for example, this example over here, print message, we could call the function print message as many times as we want. Every time we call this function, it will print exactly the thing that we want it to print, which is the message. This is a function. Are you okay?
Yes, sir.
Okay.
Yes, sir.
So look at the. I'm just using the arrows to show you something. Okay. So look at the arrows. Notice that when we are running, this is the main program. Okay. And then this is the function. Okay. Okay, so when we are running the main program, line 1, we start the program. Line 2, we print hello from the main. Line 3, when we get to line 3, notice that because this is a function, we will go all the way here to go and run the function. So we'll see this is a function. Then end function will come back and continue and then end the program. That is how that's how compilers do the job. When they see a function, they go and run the code inside the function and then come back to the program that is calling them to run the function. Okay. Are we okay?
Yes, sir, we are okay.
Okay. So let's look at more examples. So in this example, you can see that we have two functions. There's a function called first and a function called second. See, so line 1 to 3 is a function called first, and then line 4 to 6 is a function called second. Then look at our main program. So this is our main program. Okay. So in our main program, when we start the program, then we see inside function main. So we are inside main. We see that on the screen printed. Then we see first. When we see first, what the computer will do is to go all the way to where it can find first, go and run inside the inside function first, and then when it is done, it will come back to line 4. Line 4 says second. It will go and run second, see inside function second, and then when it is done, it will come back and continue back to main and then end. So I have the depiction of what it's looking like on the right-hand side. Notice that when we get to first, we go all the way and go and run this and then come back. When we come back and we see this, we go all the way, go and run this code, and then we come back to run this one. So in effect, you see inside function main, inside function first, inside function second, and then back to function main, and then you will end the program. Is it understood, please?
Yes, sir.
Yes, sir.
That is how the functions work. And they will run as many times as we want. We just need to write it once. So for example, if we have written first, and over here too we have first, and over here too we have first. So we have them 3 times. Okay, we have first 1, 2, 3. What it means is that when we run inside function main, the next line we'll see inside function first. The next line we'll see inside function first. The next line we'll see inside function first. We will keep running first as many times as we call first. Are we okay?
So if we start with the first. It will, when we call it, it will work. It will work on
To
all
go
the
and print,
yes, before
yes.
it will go to second.
Beforehand, if we started with second, it will go to second first.
And then
before
print
it will
all
now
the
finish and then go and do first. Yes,
Okay.
yes.
All right.
If we didn't include first and we only included second, it will only go and run second.
Oh, okay.
You understand? So like I was saying, even though maybe you have 2 children, if you call Amma to come and do something for you, and you don't call Kofi, Kofi is there. You understand? Kofi will sit there. You've called Amma. Amma comes to do the thing, goes back. You call Amma again. Amma comes to do the second thing, goes back. You call Amma again. Amma comes to the second thing, you go back. So you keep calling Amma. Amma comes to do what she needs to do and goes back. Okay? But if you call Amma and then you call Kofi, it means Amma will come first and then Kofi will come second. If you call Kofi before you call Amma, it means Kofi will come first before Amma will come. And that's exactly how functions behave. The one you call is the one that comes to do something.
Yes, sir. So if you have about 20 first and then you called first, all the first will come before the
Yes. As many times as you call first will come.
Okay.
Okay, thank you. So another example too as well, we have a function called A, and then we have, so we are calling A with a variable. So B contains 10, and then A, in order to go and do A, we have to what? Go and run A. A says return 5. So we have 5 plus 10. Remember, B is equal to what? 10. So we have 5 plus 10. Then the answer is what? 15. Okay? So 15 is what you see over here before you end. And this is what I'm depicting over here. When you see A, because A is a function because of the parenthesis. If you don't bring the parenthesis when you are calling it, it's not a function, it's a variable. Okay? So please take note of that. The parenthesis is very important when you are dealing with functions. You must include the parenthesis. Had we brought parenthesis over here, it means B is a function. But because there's no parenthesis, it means B is a variable. If we bring square brackets, it means what? B is an array. Remember last week we talked about arrays. Okay, so those things, the parentheses, the brackets, is very important. They distinguish one type from another. Okay, so now that we have understood what a function is, function definition, function declaration, function call, the next important thing we need to understand is the information we give to function. Okay, so maybe you create a function and you say that as for this function, if you give it a number, it will do something to the number and return an answer. Okay, so we call that arguments. The data that we give to a function or the values that we pass to a functions, they are called arguments. Now, look at this example. So in this example, we have, look at this example. So in this example, we have a variable called results. And what do you want to do? We want to find 2 raised to the power 4. In C++, we don't have a way of doing this, okay? So we have a function called power, okay? But instead of writing power, we write POW, sorry. Now you put the first number first, and then you put the second number, the index second. Okay, so you can see that we have 2 numbers, 2 raised to the power 4. Now this is how we write in C++. So these 2 values we have given to power, these are called arguments because they are the values which will now be used to calculate the power or the index of 2 raised to the power 4, which is what? 16. Okay, so 16 is what is going to be put inside results. Hope you understand that. Now, when you create the function, if you want to take arguments, then you must have parameters. So the information over here, the variable over here, which will take the argument is what we call parameter. Okay, this one is called parameter, and this one is called argument. When you, in the function call, it is called argument. Okay, so this one happens in the function call. Whilst in the function definition, it is called parameters. So this one happens in the function definition. Okay. Okay, so please take note of the difference. The arguments are actual values, whilst the parameter are variables. Okay, so please take note of that. Can you distinguish between the two? Hello, are we on the call? Still?
No.
Yes, sir.
Can you come again on that one, please?
Okay, so I said earlier that when we are creating the function, some functions take values. For example, if I say let's create a function to print your name. Okay, let's say we are creating a function to print your name. So maybe we'll say, yikes. So maybe we'll say that the function is a void function. Okay, so let me undo that. Okay. So let's say the function is, so we create function void, okay, and then let's call it print. And then because it will print your name, we need your name. So your name is a value, okay? And then let's call it n, okay? So what we'll be doing is that we want to print your name, okay? So we'll collect your name. Maybe we'll say your name is, and then we'll concatenate it with what? The parameter n, and then we'll close this one. Within the body of your code, okay, within the body of your code, you will have a function call. The function call, okay, the function call would read print, and then we'll ask for your name. So maybe you say Yao, okay? Now, this one over here is called an argument. It's called an argument because this is raw data we pass to the function. It can be a number, it can be a string, it can be a character. It depends on what this one is. So because this one says string, you can only put a string inside print, okay? So when you are doing function call, this one is called argument. But over here in the function definition, right, this one over there where the Yao is going to go is called a parameter. In the function definition, the variable over there is called a parameter. But when you are doing function call, the data, the raw data is called arguments because they are given to the function. Do we understand?
Yes, sir.
Yes, sir.
Okay. We'll
Sir,
see
please,
some
I have a
examples.
question.
Yeah, okay.
Please, when it comes to the function body also, is it called an argument?
The body, like the one over here, AMT. I'm talking about
Yes.
something specific. I'm not talking about the whole body.
I'm
I'm
saying
talking
when
about
you
something
have
specific.
a value inside a function body, is it also called an argument?
Is it a raw value or maybe something
Yeah,
like this?
raw value. Like the return is maybe 5. Is it still an argument?
It's not an argument. The argument only exists in the function call.
All right. Okay.
Okay. So it's either maybe a literal. So maybe it will be if it's a raw value, then it's a numeric literal. Okay. But the one over here, for example, the one AMT over here is called a parameter because it is inside the parentheses. Okay.
Okay.
And then if you find it in the body, for example, you see it over here as well. This one over here is also the parameter. because that's the same thing up there. Do you see that is the same thing?
Yes, sir.
Yeah. So that's that. Okay, let's look at how it works. Okay. So for example, we have a program. Okay, we have a function which is called display value. Okay. Then this function takes a parameter called num. Num must be an integer parameter. That's the rule. Because you are the one who wrote it. So if you wrote it, if you say integer, then you must put integer. You cannot say integer and then you'll be putting string or you're putting something else. Okay, so please take note of that. Then look at the main program. Look at the main program. The main program is down here. Now, if you look at the main program, we are starting the program. We are passing a value. We are printing passing value to a function. Then look at the name of the function. So look at the name of the function. So we are calling the function. This is the function call. But we are giving it 19. So 19 over here is an argument. It's a function argument. So I have the whole thing separated and then represented on the side like this. Look at the side, this side. Look at this side. So in the function call, the number you are putting inside, that number will be copied and given to the parameter. So this argument will be copied and given to the parameter. Everywhere within the function, we see the parameter, we put the number over there and we make it work. Do you understand? So the number or the argument will go into the parameter. That's what it means. So number on NUM over here will be filled with what? 19. So in actual fact, when you print this one, you will see the value is 19 because 19 was what was given to the function during the function call. If I give the function 21, then you see the value is 21. If I give the function 100, then you see the value is 100 because every number you give to the function will be copied and given to the function inside the parameters. The argument will be represented inside the parameters. I have another example. Look at this example. This one has two parameters. Look, A and B. A is an integer, B is an integer. And here in the function call, there's a function call, okay? We have two variables. So the variable num1 and the variable num2. Those variables may be contain a number or contain some number. So maybe this one, maybe this one contains maybe 100. Maybe this one contains maybe 201. So what it means is that when you run this program, 100 will be copied and put inside A, and then 201 will be copied and put inside B. So in actual fact, when you say return, you're actually returning 100 plus 201, which is equal to what? 300, which is equal to what? 301. Are we okay, please?
Yes, sir.
Yeah, so that is what, for now, we need to understand the mechanisms, okay? Very soon, when you do the programming, you will see how everything fits together. It's very, very nice when it comes together like that. It's very, 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 very nice. Okay, let's go further. The name we call the parameters are called formal parameters or formal argument. That's the official name, okay? And then arguments are called actual parameter or actual argument. That's the official name. Okay, so please take note. When I say formal parameters, I'm referring to the parameters. But when I say actual parameters, I'm referring to the arguments. Okay? Any questions so far? Next.
Sorry,
Okay.
I don't have a question though, but then I'm pleading if we are done with the class, we get audio visual so we can go over. Thank you.
Oh, okay. Okay, I think they are on the call. They've heard you. Okay, they'll make sure you have. Why don't you get access to the video?
It takes
Please,
long
the
time.
videos they don't come in early.
It's not me, please. I beg you. Okay, and remember there are a lot of classes you do. So
Yeah.
the persons responsible also have to compile the classes, edit them, and then post them. Okay, I'm not the one doing that. Okay, if I was adding that to my job, I would have collapsed by now. Okay, so the person is on the call. I'm sure they've heard you. They will help you. Okay. Okay. Let me proceed. Okay. So now, depending on the programming language you learn, okay, the passing of the arguments can be done in two ways. We have something called pass by value, and we have another called pass by reference. Now, let me explain what they are. Okay. So when we are doing pass by value, what the compiler does is to make a copy of the argument's value. So what that means is that, for example, if I have, okay, so I think, okay. So for example, if I have a program, okay, I have a program, okay, and in this program, I have a variable called num, okay, I set to 14, okay. Then I print, so you can see that, oh, the number is 14, okay? So everybody can see the number is 14. Then I give 14, remember, num contains 14, so I give 14 to the function called change me, okay? So what happens is that if I give 14 means we will go over here and come and run this one, okay? And give 14 to this one, okay? Now, the 14 is a copy, so notice that. Now, even though val is 14, I change val to 19, but I'm changing the value, okay? Then I print, now the value is, you see 19, okay? So over here, you see 19, then end. So when I end, I come back. Now, after ending or after changing the value, when I want to print, what do you think we'll see over here? You will see 14 still, even though it says 19 over here. Why do you think it is so? It is so because only a copy of the number was given to the function. The actual number was never touched. So programming languages that do that kind of thing, we call them pass by value. We call that idea pass by value. They don't want the user to change the actual parameters also, or actual arguments, right? They don't want the user to change it. They want it to remain as it is. Okay, so they make a copy of the actual parameters or actual argument and send it to the function. So it's only a copy. If you change it over here, it is still 6 over here. If you change it again over here, it is still 6. But if you change this 6 to 9, this will change to 9. So take note of that. Some of the programming languages, or most of the programming languages, implement pass by value. Then the other way, okay, we don't have that in there. Okay. Then the other way we have is called pass by reference. I think I don't have that in here. So in pass by reference, what happens is that we whenever we change what is happening inside the function, it also changes what is happening inside the main body. Okay, so for example, when we change this to 19, this value inside num will also change to 19. And then we'll see 19 over here instead of seeing 14 over here. Okay, there's a way to do it in C++. Okay, it's called pointers. And so I'm sure you will talk about it in the actual programming when you begin to do the programming. But we want to explain this concept or these ideas to you so that you understand these key ideas. Are we okay?
Yes, sir.
Yeah.
Yes, sir. I'm listening.
Sir.
Yes, sir. Talk. I'm listening.
Yes. Saying it copies, is there a function or is the same control C that copies? I just want to
No. Oh, come on. We are talking about programming. You're talking about control C. Oh, come on, my dear friend. I'm not talking about that your control C. Okay, I'm talking about programming.
Yeah, okay, sir.
A copy of the value. If I say a copy of the value, do you understand? The thing that is. Oh, do you still see my screen?
Yes, sir.
Okay.
Yes,
So
yes.
the number that is inside the variable, remember variables are containers. They contain something, okay? So the number that is inside the value or variable was passed to the function. That number would be copied to another value, the parameter called var. So now the parameter contains the number 14, okay? It's a copy. So it's still a copy. It's not the control C where you copy text. No. We're talking about actual copy, okay? In programming. Hello?
Yes, sir. Sir, we can hear you.
We can hear you. We are here.
Is it understood? The gentleman who asked the question, is it understood? Oh, who
Yes, sir.
that? Okay. Yeah. Then last but not the least, we have last but not the least, we have to talk about functions that return value. Okay, return type. Okay, so you earlier you saw the return value. Very well. So if the function is not a void function, and the function is an int, a double, a float, a character, string, or any other type apart from void, it will return a value when it is done. If not for anything, it will return 0. Okay. So for example, look at this example. In this example, we have a function which is an integer function. It's called sum. So we are going to pick num1, num2, num3, add them together, and then return an integer. Okay, so we have that written over here. Then we have the answer as results, and then we want to return results. Okay, so you use the return keyword to return a value. Are we okay? Hello?
No, sir.
Yes, sir. Yes, sir.
Yes.
So once you input return in the program, now it will.
Yes. If you have a function with a type, then you must always add return results.
Okay.
Or return something. You must return something. Yes. And those functions which are floats, okay, integer, double, character, string, boolean, long, short, signed, unsigned, all of those functions are all the types of functions which you see return. If you write a function and you put any of those things in front of the name, it means you must return something.
It's only void that you don't use return.
Yes, it's only void that you don't use return. Thank you very much. Yeah. So that is the key. And the data you are returning must match the type. Okay, so for example, this one cannot be a decimal. Okay, because I said int, I must return an integer. So notice the result is an integer. You get the rule? The rule is that if you are returning, you must return exactly the same thing you said you are returning. Okay, so if you said double, then you must return a decimal. If you said character, then you must return a character. That's how it works. Okay. So look at this example. Look at this example. So in this example, let's just see that the var1 contains the number 25. And then var2 contains the number 15. Okay? So when we write sum and we pass var1, var2, 25 will go into the position for num1. So num1 now contains 25. Then 15 will go into the position for num2. So num2 now contains the number 15. Are you okay? Then it simply says num1 plus num2. So that's 25 plus 15. So when you add the two together, okay, that's 40, I think. So now we have 40, the 35. Oh, that's incorrect. Oh, yeah. That's incorrect. That's incorrect. I think this one is supposed to be 5. Yeah. So yeah, hello. You were saying something?
And sir, please, as you are indicating in the body that var1, var2, in the function, can we use var1, var2?
Oh, but the function over here doesn't have var1, var2. Do you see? The name doesn't have to match. Oh. Look at the name. It's called num1, num2. It's not called var1, var2.
Okay, thank you.
Do you see that it's a different, do you see it? Look at the name.
Yes.
So look at this and look at that. They are not the same. Look at that. Right?
Yes, sir.
So they don't have anything to do with each other. The only thing they have to do with each other is that they are referring to the same function. Okay. So it's not by force to make sure that they are the same.
Okay,
no.
Thank you.
The only thing is that because it's an integer, you must put an integer in this one. Because it's also an integer, you must put an integer in this one. Aside that one, nothing else needs to match together. Okay.
And so what you put inside is the argument, eh?
Yes, what you put inside here is the argument. This is the argument over here. And this one is the parameter.
Thank you.
Okay. Okay. Yeah, so where were we? So I was saying that this is 25 and then this is 15. When you add it together, you get 40, right? So when you say return, 40 is what will be put in here. So it will return 40. So total will contain the number 40. Are we okay?
Yes.
Yes, sir.
Yeah, okay, sir.
So return is what will cause the number or the answer to be given to the variable total. Are we okay?
Yes.
Okay. Good. Okay. I think last but not the least, let's talk about scope. Okay. So scope defines where a particular function can be accessed from. Okay. So scope just tells you that, the function is located here or the variable is located there. Everybody can see it or you cannot see it. Are we okay?
Yes.
Scope. In fact, in programming, there are about 3 scopes, but for now, let's talk about 2 main ones. What we call global and local scope. Okay. Now, scope tells us who or how long a particular function or variable can exist within the program. Okay. So, for example, if I have a program and within the program, I have a function. And I have another, maybe part of the program. And I create a variable called A. I make it 10. And I create a second variable in the next part also called A. I make it 20. Remember, this one is a function, maybe function 1. This one is also a function, maybe function 2. Scope is what allows us to have A inside function 1, which is different from A inside function 2, which may even be different from another A inside the main program. Okay? So there can be 2 or more A within the program. But based on where they live or exist, the computer can allow them to run smoothly. Okay. So let's see this. So for example, I think I have an example. Okay. So for example, I have a variable here called num. Okay, it's an integer variable. Okay. Then within the same program, I have a function. Okay. And in that function, I have a variable called num. Now, this num variable only exists inside the function called test. Whilst this other num variable exists inside the main program. The computer knows that this num exists inside test. And basically, we call it a local variable. It is only local to the num which is here. It's only local to the test or the function which is here. But this num is also exists inside the main program, and it is called whenever we are inside this main program and we call num. This is the num that will come. But whenever we are inside this function and we call num, this is the num that will come. So this num refers to this num, but this num refers to this other num. Are you understanding what I'm saying? I'm saying too many nums.
So when you're calling the num, do you have to specify?
Some languages have the feature for specifying, okay, but most of them don't have that feature. And what the computer does is to default to the specific one you are in. Okay. Now there are the one I skipped. Let me read it out so that you can maybe to help with the understanding. So there are 3 main kinds of scope. Okay, we have local scope, we have global scope, and then we have block scope. When we say global scope, it means that the variable is declared so that every part of the program can use that variable. Okay, so there are some places within the program when you create a variable, all the functions can see it and use it. You can also see it and use it in your main program and use it when you call the program. Okay, we call this kind of variable declaration global scope. Okay, then when we say local scope, what it means is that the function only exists in a specific part of the program, or that variable only exists in a specific part of the program. It is local to that part. When you leave that part of the program, nobody else can see it or access it. You can only see it or access it in the main or in the part of the program where it is created. Then block scope is when you declare a function within a block. For example, if you use maybe a counter variable inside a for loop. Okay, so for loop, you create maybe int I equal to 0. That int I you created inside the for loop only exists inside the for loop. When you leave the for loop, the int I does not exist again. Okay, so that block, you can only find the int I. When you leave that block, you will not find the int I anywhere else, or neither can you see the value of int I anywhere else within the program. Okay, so that's the block scope. Okay, Okay, so let's come back and then I'll demonstrate what I mean. So for over here, for instance, local scope, this is local. It's local because it only exists inside test. So when I call num, this is the one that will come. Okay, now this is also local because it only exists inside this program. When I call num, this is the one that will come. Okay, so it's local here, local here, local here, and local here. Now, when I say global, it means where I have created the function or the variable. When I call the variable in any part of the program, I'll still see it. So, for example, I create a variable over here. It means we can all see it. Look, it's up here. It means Grit can see it, and then your main program too can see it. Now, when I call message, message is not created inside Grit. So it is global. When I call message, it will go and print this one. Do you see that? Then when I also call message, this one too will go and print this one. Hello, am I still on the call? Do you see that?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So global means everybody can see it and use it, whilst local means only you can see and use. So for example, if within Grit, I created a variable called A, and then maybe I set it equal to 10. Now, A is local, only to Grit, because only Grit, it is inside Grit, only Grit can see it. But message is global because every part of your program can use message. So that's the key difference. Message is global, whilst whilst A is local to Grit. Any questions? Okay, another example. So over here, look at where we created. Usually, it depends on where you create it. So look at this one. So over here, look, this one is a global variable because it has been created at the very top. Hello. Hello. Okay. So,
hello, sir.
Yeah, I was just telling the guy to mute his microphone. That's it. So, so for example, we create this one up here, okay? And then we call num. Now, depending on where we created it, look, num is up here. So it means every time we call num, this 12 will be printed. Every time we call num, this 12 will be printed. Do you see that?
Yes, sir.
Yes, sir.
But when we change the value and we try to do this one, it is this one that will print. This change only exists inside test, but it does not exist inside the main program. Okay, so please take note of that. Okay, so for now, these are the key things that you need to learn about functions. In the future, you learn about how to actually program using a particular programming language, and you learn more. And in fact, you'll be bewildered, and then you enjoy yourself when you are doing these things. Okay, I will not want to add more again, but I want to take questions. Next week, we will do questions, solving more questions. So next week, when we meet in person or in person class, I'll take my assignments and then we'll do questions. The whole 2 hours we'll solve past questions. So please come prepared to answer questions. Okay?
Hello,
yes.
sir.
I want you to be prepared for exams. Okay, so you come and then we solve questions.
Hello, sir.
Yes, sir.
Please, will you make the past questions available to us before we come, so that at least we can start preparing?
Oh,
yes, sir.
I'll bring. It's not questions from your program, or it's questions from different places. So I'll bring my questions from different places.
Sir, but also we've gone to the MyLoft. So we are looking for past questions with your name on it specifically. We can't find
with my name.
Yes, sir.
Oh, senior.
We should answer all of them. So because we are doing long distance, we have
yes, I know, but I don't know why you want to get passwords with my name. I don't have passwords with my name on it too.
So I think you mean a program, structured past questions on structured programming.
Yeah. So you go and get past questions. Me, I'll bring questions I have, and then we'll solve.
I say he's bringing his bank of questions, so we should.
So we'll solve. By even one questions with my name on it there, I don't know. That one you search for long.
Okay, sir. Then please we'll work on that next week. Sir. Thank you.
Yeah. Any questions for me for today? Please go and Please do all the weekly assessments. Remember, we need to get them for your continuous assessment. So please do all the weekly assessments. Make sure you score them well, so that we can we can make good progress on the continuous assessment. Okay.
Yes, sir.
Yeah. Any questions about this week's lecture? If not, then we'll call it a day, and then we will continue in person next week. Hello.
Sir, please.
No question, sir. Hello, sir. Sir, please, I have a question.
Yes.
Sir, please, with the the example on the screen.
Yes.
The first now has a global scope, and then the one in the test function has a local scope, right?
Let me see. Which one are you talking about? This one, global scope.
Yeah, that's global, right?
Yes.
And then the one in the function, the one you said to 50 has a local
we are
scope.
changing. Yes. So no. So it's referring to the same num, but we are changing it, and the change only exists inside this.
Okay.
It's the same num. You see, we are not creating a new variable called num. You can see that, right?
Okay.
So that's why I said local value change. It means the change is only happening inside test.
Okay.
It means
what I wanted.
If you put if you try to print num again, num will still be 12 over here. Num will not be 50. Okay. Num is only 50 inside test. Num is not 50 outside test.
Okay.
Oh, go on. You were going to ask a question.
Yeah, what I wanted. So apart from the scope, it means that the order of the variables is important. Right?
Yes. Very important. Very important. Okay. The order. In fact, it's the order that will make the scoping possible. Okay. So because this one is up here before all of that one, that is why it is global. Okay. If it were anywhere else, it will not be global. Okay.
All right. Thank you.
You're welcome, sir. Thank you so much for your good question. Very good question. Okay, so we'll call it a day, right? Let's call it a day, and then we will see each other, God willing, next week. Okay. Thank you very much. Enjoy the best of your day. Next week, questions galore.
Thank you, sir.
Thank you, sir.
Yeah. You're welcome.
Asembeba Devi.
This video is still being recorded.
Recorded by who?
Guys, when will you guys stop all these things? Like, it's not nice.
Akim.
Mr. Kumsing.
Akim, the programming doctor.
Hey, me, I mean, who I don't know.
This one, too, unless we come less.
Nyame ti ase no na mebisa. Program ne de easy. Ebefa. This is the theory side.
Something
Hopefully.
from you.
You see?
Now they say this one, too, unless we can learn something from you. This programming.
Please, you guys should stop the conversation over here. Oh.
Say again. I don't know nothing. Name of Baba.